Hi, my name is Erin Meyer, and I'm going to tell you about why to use a temperature sensor. So why send a temperature sensor to the moon? Well, the temperature sensor played a critical role in the Apollo science missions. GLIA is a temperature sensor that can conduct science investigations for regolith heat transfer, investigations that complement or support lunar orbiter observations, also investigations which look at differences in ambient temperature at different times and locations. Lastly, environmental health monitoring of the LunaSat overall. This information is useful for future missions that are more sensitive to changes in temperature. So some background information on the comparison between Earth and the moon. On Earth, when a LunaSat is sitting face up in a room, it measures the temperature of the room. On the moon, however, if we put the LunaSat face up on the moon, it will not measure the temperature of the moon since there are no air molecules. Instead, it will measure the temperature of the LunaSat. We will be experimenting with this more with the LunaSat temperature change on Earth with an understanding that it will not work exactly the same on the moon. To measure the temperature of the moon, we use a different sensor called the thermopile, which we will see in Module 8. So temperature measurements can be taken as local or distributed. Firstly, for locally, we get some information from each individual LunaSat over time. More information about the effect of the lunar surface on the LunaSat temperature over the course of a lunar day could lead to more sensitive sensors that can be better calibrated and reinforced to work properly in the lunar environment. Also used to determine if modifications would be necessary for future missions. In addition, for distributed is taking multiple LunaSats and can be used to study how temperature varies over a surface. Just imagine you have 100 people standing in a field. Some people will be laying on the ground, some people will be hiding from the sun, some people will be facing different directions. And with all this, there's different orientations and different exposure levels that they will receive. Similar to the LunaSats, by comparing the temperatures from people at different orientations, this can tell us more about the changes in the temperature across the field over time. So in summary, a temperature sensor on the surface of the moon could provide more information on how the moon's thermal environment affects hardware. This could lead to better development of future landers and more effective in creating simulations and testing for future exploration and/or research missions. The temperature sensor can measure and record the temperature of the LunaSat over the course of a lunar day, and it is useful in indicating if proper operating conditions of other sensors were met. In addition, with the local and distributed science, we can disperse temperature measurements over a lunar day to help science communities better understand data collected.